So here is the first question, the 11th question. We have two cylinders A and B. A is weighing 200 newtons and B is weighing 100 newtons. They are connected by a bar of negligible weight. We have to just neglect the weight of the bar. And it is resting on the smooth planes, which means the friction has to be neglected. There is no friction involved here. And we have to find the force P, which is inclined at 60 degrees with the vertical, acting on the point B, and that should keep this system of bodies in equilibrium. So here I have redrawn the diagram. So this is the force P which we have to find. This is at 100 newtons, the weight is acting straight downwards. 200 newton, the weight of A is again acting straight downwards. The link AB will put forces on both A and B. It will try to push A in the left side and B on the right side. So if when we take the free body diagram of the two spheres, for A we should take it to be acting on the left side, and for B we have to take it to be acting on the right side. Of course, there are two surfaces where the spheres make contact, and at that contact point we will get two reactions. Let's call them as N and M. So let us start solving it. First, let's take the free body diagram of A. It will be same here. We just have to ignore this point. We just have to cut this off, and we just have to ignore the surface of contact. We have already replaced this surface with its equivalent force N, that is the normal reaction at that point. So we can see here that there are overall three forces acting on the sphere, and they are keeping the sphere in equilibrium, and that tells us that we can actually apply the Lami's theorem, since all the conditions required for applying Lami's theorem are satisfied here. But before we set out to apply the Lami's theorem, we will have to find all the angles. Right? So all these angles we need to actually find before we could apply the Lami's theorem to this. First up, the angle of the normal reaction from the vertical will be same as 60 degrees. Fine. So this 60 degrees will come over here. Next, this angle, the angle of this rod from the horizontal is 15 degrees. It will be same from this direction. So now, using these two values, we can find almost all the values that we need. So this angle here will be 90 minus 15. That's 75 degrees. Now let's proceed to apply the Lami's theorem. First, we will take the known force of 200 newtons divided by the sine of angle between the other two forces, and that is 60 plus 75. This is equal to the next force. We'll just go with the normal reaction, N, and N divided by, again we have to take the sine of angle between the other two forces, that's 90 plus 15. And finally the last force is C, that divided by the sine of angle between the other two forces except for C, and that is 180 minus 60. So since we are interested in finding P finally, we don't have to find the normal reaction, we just need C. So we'll just have to use this and this equation. Comparing them, we will be able to get C as 200 times sine of 180 minus 60 whole divided by this value, the sine of 60 plus 75. Calculating this with the calculator, we get this value, 244.95. Since all the forces are in newtons, so here also the unit will be newtons. Next, let's take up the free body diagram of B, and this is what we have to solve next. Since there are a total of more than 3 forces acting on this sphere, we cannot go ahead and apply the Lami's theorem. We will have to go with the sigma h and sigma v. So first let us go with sigma h. So once again, before going for that, we will need angle of all the inclined forces with either the vertical or with the horizontal. So this force, the reaction M, its angle with the vertical will be 45 degrees, and the force of P, this side of the angle is already given to us in the question, that is 60 degrees, and that angle is with the vertical. So now that all the angles are known, let us find all the horizontal components. This force of 100 newtons is vertical, so it will not have any horizontal component. The force C will have a horizontal component of cos 15, and it is acting on the right side, so it's going to be positive. Then of course this will not have any effect. P will be acting left side. The horizontal component of P is acting left side, and the component itself is P sine 60. Then the horizontal component of M is also acting on the left side, and the component is M sine 45. So that completes all the forces. This total has to be equal to 0. So here we have already found the value of C, which we can substitute here, but the other two forces are still unknown. So let's send them both to the other side. Now we get P sine 60 plus M sine 45. Now let's just give it an equation number and proceed for the next one. The next what we have to do is we have to find sigma v, sum of all the vertical components. Now 100 newtons is already vertical, it's acting downwards, so it's going to be minus 100. Then the component of C in vertical will be C sine 15, and it is also acting downwards, so it's going to be taken as negative. The component of P will be P cos 60. Once again, it's acting downwards, has to be taken as negative. The component of M, however, is acting upwards, so it's going to be positive, and the component is M cos 45. Now the total of this once again has got to be equal to 0. Once again, let us substitute the value of C here and find another equation. So it's minus 100 minus C value 244.95 into sine 15, and the remaining terms let us send to the other side. It becomes P cos 60 minus M cos 45. So this equation we will call it as equation number 2. Now these are equations in two variables with x being replaced by p and y being replaced by m. So we all know there is an equations mode in the calculator. So just feeding these into the equation mode in the calculator, we will be able to get the value of x and y. We just have to replace p with x and m with y, and substitute all the coefficients here in the calculator, and when we press equal to, we will get both the values here. So that's what. This is the solution to our problem that we need, and that is how we solve it.